Hello, hi. Have you ever done a test on something or let's back it up. Have you ever done a math problem? You and your friend, you're in class and you both have the same exact problem and you do it and you get, let's say, 10. And your friend does the same exact problem and gets the answer of 6. Who is right? So today, that's what I want to talk to you about. I want to talk about test performing on an object or a product and coming up with the right answer and how to determine if you're coming up with the right answer. So I'd like to introduce myself. My name is Barb. And the current situation that I just spoke about a few minutes ago is happening currently in my workplace. So I work at a tier one automotive supplier, and we have many suppliers from different commodities. The problem that we have is our supplier is supplying us with 10 to 15-foot long steel tubes that are welded together with a little seam that is 50 millimeters wide. So a very, very small range. Now, when these bars come in, there is specs that they have to meet. So our Met Labs perform a test on that weld seam across that bar. Now, for the past couple months, every weld seam that our Met Lab has tested has been out of spec. They've been too hard. And when that happens, we cannot use the material. So why is that a problem? Because now our plant is faced with this problem of not having material for our assembly line. And since we're a tier one supplier, that means we have an automotive supplier that we supply to. So if we have to shut down our lines, that is going to do the same thing to them and shut down their lines. And if anybody knows about the industry, automotive industry, it's not a good thing to shut down your customer. So now we're faced with this problem of our tubes, our incoming tubes from our supplier have this out of spec hardness, weld hardness. So now what do we do? What do we do? So the whole point of this was to come up with a solution. So that is what I have done, and that's what I'm going to propose to you today, our solution for these incoming tubes that we receive from our supplier that have weld seams that do not meet our product spec. So going through and using Six Sigma tools and methodology is how I came about the solution for this problem. So there's many tools of Six Sigma, and I'm not going to go into depth on it because that's not the point of my presentation today, but I just wanted to make you aware of how I came about to my solution that I'm proposing. So the first step that I had to do was I had to learn the process. I had to learn the process for the supplier and our Met Lab. How was each place checking it? Remember in the beginning of the question I asked, you had a math problem, your friend had a math problem, you both did it, but you got wrong answers, or excuse me, you got two different answers. Who had the right answer? We don't know yet, right? Because we don't know which testing method or which method you used to solve that problem was correct. So visiting the supplier, I learned their process. I documented everything, and they went through and they would measure the tube. So there was a seam right on the top, and they would measure. Actually, I have a picture. So this is the top of the tube. I'm not sure if you can see it. See the tube there? And in the center here, that is the weld seam. Now that's where the indentations are taking because that's what gives us our hardness result. So when I was at the supplier visiting, they did 3 indentations along that weld seam. They weren't concerned about, remember I said it was about 50 millimeters wide, the weld seam. They were concerned about where the position of the indentation was as long as they had 3. And then they recorded their result, as long as the result, they recorded the highest, as long as the results were all within spec. That was the one they recorded. So, okay, fine. So now, remember how I said the steel, the bar was 10 to 15? So before, I should have explained this. Before I went in there, I took sections of the same bar. So I know I was working off the same weld seam. So I took that, another section from that same bar to our Met Lab out at my current workplace and asked them how they measured. So I went out there and they cut the bar in half. Just, I didn't say nothing because I wanted them to finish their procedure of what they were doing. And what they did is they checked the ID of the weld seam. You can see the weld seam on the outer of the bar and the inner. So they were taking measurements on the ID. And they took 5 impressions and then they recorded the average of those 5. So after using my Six Sigma methodology tools, I learned that there is a proper location to take these measurements and indentations on the steel tube. There is a study, and I can show you a picture. So it was very important to make sure that your indentations were within that 50 millimeter range. You want it to be in the center as possible. Now this blown up study, I'm not sure if you can tell, but there's variance. The farther we got out from the weld to the outer edge of the weld, we had more variance. Now this caused, remember I said, our plant had different results. Ours was rejecting it, saying they were too high than the supplier. So our problem was not only having steel tubing that we couldn't accept, but also our supplier and our Met Lab were not aligned on their measurement systems. So that is my solution that I came to. Our Met Lab and our supplier need to align to have the same measurement system. And what they need to do, after learning where the most important part is to take the indentations on this part, we created work instructions for them to both take measurements on the OD of the bar. They're going to take 5 impressions. It's going to be within the weld seam in the very center. They're going to take the average of those 5 after the indentations, and that is going to be recording. Both places will be doing the same exact thing, so there'll be no confusion. Just like earlier when your buddy was doing the same problem as you and you were doing it this way and you came up with 2 different results. Well, the actual answer was 9. It wasn't even 10 and it wasn't 5 because you were both doing it your own way. So aligning and doing it the same way allows us to come up with the same result. And it's our confidence, our capability of coming up with the same thing increases. So this is the solution, aligning both of the testing methods at the supplier and our plant. So what we need to do is we need to control this, make a new purchase spec, and put this out to the supplier ASAP so we can stop having incoming material where both places are not measuring the same, because we do not want to face that risk of shutting down our plant or our customer as being a tier 1 automotive supplier. So thank you. My name was Barb, and it was nice to speak with you today, and I hope to see you all again. Bye.